Hello everyone and welcome to MacTech 14, and today we are going to solve one question of Engineering Service 2022, that means the recent paper, and this is the question number 3A from paper 1. This is a very fantastic question which is considering all the formulas related to testing of IC engine. So I'm directly starting solving. This is a 20 marks question. It is very easy question, but calculations involved in this question are quite long. So I'm directly writing given data. So there is a 4-cylinder, that is number of cylinders K, that is 4. A 4-stroke petrol engine has a stroke length. Stroke length is what, 90 mm, or you can say that 0.09 meter. And bore diameter 60 mm, that is 0.06 meter. And RPM is given 2800. The engine is tested at the rated speed against the brake, which has the torque arm, and torque arm, that is small l, 0.356 meter. And the brake load, that is W, given as 155 Newton. The fuel consumption, that is volumetric fuel consumption, is 6.74 liters per hour, that is given, and specific gravity of fuel is also given, that is 0.735. The net heating value of the petrol used is, that is calorific value, CV, is given 44,200 kilojoule per kg. Now the Morse test data, that is when cylinder 1 is cut off, 2 is cut off, 3 is cut off, 4 is cut off. So as we know, when one of the cylinder is cut off, so the brake power will also reduce. So corresponding brake load I am denoting with BL1 when cylinder 1 is cut off, that is 111 Newton. BL2, that is 106.5 Newton. Brake load when third cylinder is cut off, that is 104.2 Newton. And brake load 4, that is 111 Newton. Calculate for this speed. What we have to find is, first, that is engine torque. Second thing, the brake mean effective pressure, so PBM. Third one is brake thermal efficiency. Fourth one is specific fuel consumption. Fifth one is mechanical efficiency. And sixth one is indicated mean effective pressure. I am denoting with PIM. So first, I am finding torque. So torque we can find out by W multiplied by small l. So W is what? That is 155 multiplied by 0.356 arm length. So you will get as a 55.18 Newton meter. Okay. The second thing that we have to find is brake mean effective pressure. So we can find out the formula: brake power is equal to brake mean effective pressure multiplied by stroke length multiplied by piston area, that is N RPM, number of cylinder, K, divided by 60, divide by 2. Why here N by 2 this term? Why? Because Morse test is only conducted for multi-cylinder 4-stroke engine, and we know that for the 4-stroke engine the effective RPM will be capital N by 2. So but we don't have the value of brake power, so say it as a equation number 1. Now how can we find out the brake power? So brake power is equal to torque into omega, that is torque into 2 pi n by 60. Torque is 55.18 multiplied by 2 pi n is RPM is given 2800 divided by 60. So when you solve this, you will get as a 16.18 kilowatt. Answer in kilowatt. Now substitute this value in equation 1. So 16.18 is equal to brake mean effective pressure multiplied by stroke length is 0.09 multiplied by pi by 4 into 0.06 whole square, and RPM will be 2800. Number of cylinders are 4 divided by 60 multiplied by 2. So when you solve this, So you will get the brake mean effective pressure as a 6.81 in bar. Generally you have to substitute in bar, 6.81 bar, and that's the answer of our second question. This is the answer of first question that they ask. And now third thing is brake thermal efficiency. So brake thermal efficiency we can find out by brake power upon mf into cv, but we don't have the value of mass flow rate of the fuel, so say it as a equation number 2. Now we have to find mass flow rate of the fuel. So we have given the volume of fuel, volume flow rate, that is 6.74 liters per hour. So we know that 6.74 we have to convert in meter cube. So 6.74 10 to the power minus 3 divided by 3600 meter cube per second. If you want to find out the mass flow rate, then we have to multiply with specific gravity, multiply by 1000, multiply by volume flow rate. So specific gravity is given 0.735 in question, multiply by 10 to the power 3, multiply by 6.74, multiply by 10 to the power minus 3 divided by 3600. So when you solve this, you will get as a 1.37 into 10 to the power minus 3 kg per second mass flow rate. So put this value over here. We have brake power, that is 16.18 in kilowatt. Mass of the fuel is 1.37 into 10 to the power minus 3 into 44,200. So when you solve this, you will get as a brake thermal efficiency 26.27%. So this is the answer of third portion that they have asked. Now the fourth thing is, that is specific fuel consumption, SFC. The specific fuel consumption, that is given by 3600 divided by brake power. So 3600 divided by brake power is 16.18. So when you solve this, you will get it as a 222.5 kg per kilowatt hour. This is the unit, 222.5 kg per kilowatt hour, and this is the answer of our fourth portion that they've asked. Now fifth and the most calculative part, that is a mechanical efficiency. So we know the formula of mechanical efficiency, brake power upon indicated power, but we don't have the indicated power right now, so say it as a equation number 3. I think equation number 3 is there, yes. So say it as a equation number 3. And how to find indicated power? We know that for Morse test, indicated power for engine is equal to summation of I is equal to 1 to 4, and here 4 cylinder is there, so I is equal to 1 to 4. If there is a 6 cylinder, so I is equal to 1 to 6, the individual IP, summation of IPI. And how to find summation of individual indicated power, that is total brake power minus individual brake power when one of the cylinder is cut off. So we have to find BP minus BP1. If first cylinder is cut off, that is BP minus BP1, that is brake power 1. So brake power when cylinder 1 is cut off, that is given by brake load in first when one cylinder is cut off, BL1, that is brake load when first cylinder is cut off, multiply by arm length, multiply by omega. So what is the brake load? That is 111 Newton. Arm length we know 0.356. Yes, I think arm length is 0.356, yes. And RPM, omega is equal to 2 pi n by 60, that is 2 pi n by 60. So brake power when cylinder 1 is cut off, that is 11.586 kilowatt brake power when cylinder 1 is cut off. Now similarly we can do the calculation when brake power when cylinder 2 is cut off, that is 111 value, that is the load value corresponding to BL2, that is brake load when cylinder 2 is cut off, that is given in the question is 106.5 Newton. So when you calculate this, you will get as a 11.117 kilowatt Now brake power when cylinder 3 is cut off, that is 10.887. Why I'm writing this value directly, because you have to just change the value of brake load and all the things will remain same. And when this is a 11.586 kilowatt. So now indicated power, individual indicated power, that is IP1, that is total brake power minus brake power when first cylinder is cut off. Total brake power is 16.18 minus 11.586. We have found out PP1 here. So you will get as a 4.594 kilowatt IP1. Similarly, IP2 indicated power when second cylinder is off, the same thing, 16.18 minus BP2, that is you have to multiply minus 11.117. So when you do this, 16.18 minus 11.117, so you will get as a 5.063 kilowatt. IP3, similarly you will get as a 5.293 kilowatt. IP4 when cylinder 4 is cut off, that is 4.594 kilowatt. These are the four results of indicated power. So what we have to do is we have to find out the total indicated power by using this equation. Say it as equation number 4 and say it as equation number 5. So using equation number 4, when you do the summation, 4.594 plus 5.063 plus 5.293 plus 4.594, so you will get as a 19.554 kilowatt. So substitute this value, indicated power, in the equation number 3. So mechanical efficiency that we can find out as a brake power, 16.18 divided by 19.554, that is answer is 82.78%. 82.78%. This is the answer of fifth portion, and this is the most calculative part. Now the last part, that is sixth part, that is indicated mean effective pressure. So it can be found out by indicated power upon indicated power is equal to indicated mean effective pressure into LAN K 60 by 2. So indicated power is what? 19.544 is equal to indicated power. We have to find out L is 0.09, that is pi by 4. There's piston cross section area 0.06 square. RPM is 2800. Number of cylinders are 4 multiplied by 60 and 2. So when you solve this, you will get the indicated mean effective pressure, that is 8.06 bar. That is 8.06 bar. That is the answer. And all this answer are we have found out, and our question is completed. Now the main thing is self check in the exam whether we have solved correctly or not, because we have done this much of effort, and if our answer is getting wrong due to calculation mistake, then it will be a very disappointing. So how to check it? So first check brake thermal efficiency. So you have to remember something, that whenever indicated thermal efficiency and brake thermal efficiency is given, so its value lies between 20 to 30%. Okay, and your answer is coming between 20 to 30, then your brake thermal efficiency is correct. So whatever your mass flow, mass of fuel value, and all this value are same. Now second, if your mechanical efficiency is coming out 83%, then your answer is correct. That means your indicated power calculation as well as your brake power calculation is same. Indicated power as well as brake power calculation is true. Now for checking brake mean effective pressure, that is 6.81 bar, and indicated mean effective pressure is always slightly higher, or so that is here 8.06 bar, and the brake mean effective pressure in this case it is 6 bar. So again, indicated mean effective pressure is higher compared to brake mean effective pressure. So that is the self correction. It should be like this. otherwise your answer is wrong. So these are the some self checks in the exam that your answer is correct or not. So this is all for today's video. I hope you like this and you enjoyed the solution, and we will meet tomorrow with some new question and some new self correction methods. So keep studying and watching our previous videos also, and subscribe this channel and like this video and share with your friends also, so that they will also get the benefit of this. Thank you.